Today, we're going to take a closer look at the AZDOME M550. We've got some professional lab tests lined up, followed by a full chip-level teardown to see the internal hardware. We'll start in a professional lab, testing resolution, HDR, 3DNR, and duplicate frame rates to give you a clear baseline. We're using the Viofo A229 Pro as a benchmark. All tests are done simultaneously, in the same scene, and under identical lighting to keep everything fair. Let's get into it. First, let's examine the resolution of the M550. As we approach the number 14 mark, the separation between the black and white lines begins to soften. The 5 individual lines eventually merge into a single gray area. This indicates that the M550's resolving power reaches its limit between 14 and 15. The M550's performance is consistent with 2K resolution standards. Next, looking at the A229 Pro, the lines remain distinct and sharp, even as they pass the number 18 mark. High contrast is maintained between the black and white segments. Even at the finest scale of 20, each individual line is still clearly visible. This performance places it within the higher tier range of 4K resolution standards. Next is the HDR comparison. Under the same lighting conditions, the A229 Pro manages to keep the light tubes under control with minimal flare. Under the same lighting conditions, on the M550, we see more noticeable flare from the lights, which actually ends up obscuring the last digit of the plate. Now, let's look at the wide-angle comparison. The A229 Pro claims 140 degrees, while the M550 claims 150. The A229 Pro's field of view actually looks a bit wider. Let's look at the 3DNR performance. In nighttime conditions, the A229 Pro keeps the image clean with minimal noise, and the license plate remains sharp and stable. On the other hand, the M550 shows more noticeable grain and noise, making the plate a bit harder to read clearly. Finally, let's check for duplicate frames or stuttering. I'm playing both clips side by side at 0.3 times speed. As you can see, the motion is perfectly smooth on both devices, with no freezing or frame skipping detected. Both maintain a 0% duplicate frame rate. That's it for the image comparison. Notably, the M550's resolution performance is more in line with high-end 2K. Both units were rock solid though, with 0 duplicate frames. Now, let's get into the teardown. Starting with the exterior, I've pre-removed the side cam to focus on the main unit. The shell feels solid, no cheap plastic vibe here. On top, the magnetic mount doubles as the charging port with a snappy snap. Below, we've got 5 physical buttons. Prying open the outer casing now, and the motherboard and ribbon cables are clearly visible. We're peeling back the insulation tape to separate the motherboard from the display. Here is the screen. Now, removing the motherboard. After unscrewing the fixed points and gently lifting from the gap, we can open it up to see the full layout. The internal wiring is somewhat scattered, and the ribbon cables are relatively long. Here's the ribbon cable for the supercapacitor, which is also relatively long. Prying off the shielding cover now. Once it's open, we can see that there is no thermal pad applied on this side of the shield. We can now see the ribbon cable for the image sensor. That's the one for the lens right here. Over here are the ribbon cables for the GPS and the charging interface. Moving over, this is the Wi-Fi module, and right next to it is the flash memory chip. Now, we're removing the clips and insulation tape securing the motherboard to take it out for a separate observation. Coming to the side, here is the memory card slot. Below that appears to be the data transfer port. On the other side, we have the interface for the rear camera. Continuing to pry open the shield on the other side. This blue piece here is the thermal silicone, and it looks somewhat thin. After a quick cleanup, we can now see the specific models for the main controller and the DDR chip. The main controller is the Novatech NT96670BG. Right below it sits a genuine Samsung 256 megabytes DDR3L high-speed RAM chip. The speaker wires look relatively thin, so the power output should not be very high. Now for the supercapacitor. It's rated at 3.5 farads / 5.5 volts. Now we're disassembling the lens module. A lot of tinfoil is used around the lens here to prevent signal interference. And underneath, there's also a layer of conductive cloth. Opening this up to check the sensor connection. It's an FFC ribbon. Its interference resistance and durability are generally inferior to FPC. So using FFC here is likely a compromise made to save on cost and internal space. The sensor is confirmed as the GC4653. The GC4653 is a 2K sensor, meaning the M550's 4K is upscaled, not native. Continuing to take it apart now, this is the magnetic mount we removed at the beginning. Now, let's take it apart. This part uses adhesive. There are a few screws here on the mount. Let's get those removed. With the screws out, we can now pry it open. Inside, we find the magnetic power module and the GPS module. Continuing the teardown, let's take out the power board and have a look. This magnetic board is the primary method for powering the device. While it looks sophisticated, this multi-pin design may be more prone to contact failure in complex environments. Finally, let's take a look at the GPS module. The model number is HS-G1818M. All right, that wraps up the teardown. In summary, the hardware limit of the sensor is 2K. The 4K output relies entirely on software upscaling, which explains the gap in fine detail compared to native 4K products. The A229 Pro. While the design looks high-tech, the internal wiring and connector choices suggest a heavy focus on cost balance. That concludes our teardown of the AZDOME M550. I'll see you in the next one.